Topic D, encapsulation and information hiding. Now, when you're talking about data or information, in object-oriented programming, you're almost always talking about attributes. Now, if you think about attributes of an object, not all attributes are equal. Some are going to be bound to change, they're variables. Some are basically constants, should not change. Some you want your, other programmers with access to the class to change because they are regular operations with the object. And some you should be very careful when changing. So let's think of an example we've covered before, cars. In cars, you have attributes like make, model, year, top speed. So let's think of them. For example, make and year. You cannot change the year in which a car was made, right? The car was made in 2010. I can't change it so the car was made in 2007. It's not possible. Time travel, in reality. I cannot change a Mazda to a Ferrari, not gonna work. But I might be able to change a model. I might be able to change a 3 to a 6. Maybe they have similar panels or parts. It's conceivably possible. Particular car brands like Toyota standardized engines across models and panels across models. So not all data is equal. Not all attributes are equal. And encapsulation and information hiding is essentially about which of these attributes are accessible and which of these attributes have methods to change and manipulate them. So the best way that I can summarize encapsulation, it is something that we use to limit and guide how user accesses and changes data within objects. Now, there's also this notion of data hiding, and that is you can have attributes that are not instantiated in the init class, that just exist there, that have no ways to change them via methods. So you can have information that is hidden, that is useful, but the users of the class are not even aware that it exists. Now, the two mechanisms that Python has to sort of keep information protected or hidden are essentially protected and private attributes. So protected attributes are just marked with a little underscore, and they should not be changed. They're just like a little etiquette note of a developer to another developer. Probably don't change this attribute. Like the model of a car. 99% of cases you will never change the model of a car, but it's something that's possible. Whereas the private ones, well, it's like the make and the year of the car. That's you're leaving the plane of reality when you change that. So those cannot be changed. Python is hard-coded to make those impossible to change. So let's have an example of protected attributes. Underscore model is a protected attribute. You create a car, make, model, year, and you print the car model. So first of all, you can print it. You can access it. You can change it. And then when you print the car dictionary, it's permanently changed. Whereas the other two, make and year, you can print mycar.make. The object is not attribute. So you can't even print it. You can't even view it. And that is an example of a private attribute. So here is our class car with private attributes make and year and protected attribute self. So what that means is that, first of all, I can print the dictionary, but if I'm trying to print individual attributes, I will be okay if I try to print my car.model, and that will print 6. But if I try to do the same for make or year, I cannot access those attributes. In fact, it's like they don't exist. No attribute underscore year. So what I want to do is create some methods that help you access these attributes. So you should be able to access all of them, make, model, year, to C, because these are valid information about a car. But you should only be allowed to change the model. So doing so will set the rules and regulations what you can do with car objects. So I'm going to basically outline the methods first. So I'm going to do this: def get make, and these don't take any parameters. It's going to be pass We can do def get model pass. We can def get year pass. And then what you want to do is be able to set the model, because that could change. So we could set model and pass. So let's get started. First with the make. All we need to do is return self.make. Remember, double underscore make. For the get model, we'll return self.model. For the get year, we'll return self.aha. This is really commonly forgotten, self.year. And finally, set model. Well, we should basically say self.double under, or no, it's a single under for model equals to whatever we want to set. So that is going to have a parameter new model. So we have built in the functionality in such a way that essentially, I don't know what just happened there. I was missing a dot. No, everything is self comma new model. Okay, so where was I? Essentially, you're allowed to see make, model, and year because that makes sense. You should know the cars in your database. What is their make, model, and year? You're even allowed to, because it's conceivable that you could upgrade a car to be a newer model, you're allowed to set the model, to make it a different model. But you're not allowed to change the make or the year because, well, you know, you cannot make a car into the future, into the past, or you cannot change a Ferrari into a Jeep. So all of these rules and regulations in terms of what you can change in cars are written inside these. These are known as getter and setter methods, and this is best practice in object-oriented programming. So this is, you know, a very simplified but an ideal car class in terms of the way it should look. So there's nothing left for us to do other than try out these methods. So we can print get my car dot get make, get model, get make, and my car year, that was causing an error. We can get rid of that. My car get make, that's a Mazda. We can basically my car dot set model. Well, let's say there's some other model called 6X. When I play this, that's going to be the new model of the car.